So today we're going to continue our exploration on solving trig equations. But we're going to run into trig equations that don't work out to have nice values of ones that we've got memorized. Like, let's say the sine of pi over 6 or the cosine of 5 pi over 4 or something to that effect. What we're going to have are equations that look something like this. So let's say we've got the sine squared of x minus 3 sine x plus 1 equals 0. Now, first thought on that is I've got everything over on one side. It's quadratic. I've got 0 on the other side. So I can start factoring, set those factors equal to 0, and see where that takes me. But this doesn't factor. So we've got to have another strategy, another idea on where we go from there. So what we're going to do now is introduce using the graphing calculator. For sake of convenience, since we're in an online environment now, we're going to use Desmos to do that. Okay, so here's how we're going to use Desmos. We're going to go ahead and type this equation in to our box 1. I'm going to call it now y equals. And to type in sine squared, I'm going to type sin. And I've got a couple options. There's a little keyboard here. I don't typically like using the keyboard because it's just a little bit clunky. But if you want to do a square, look at on your keyboard, number 6, there's that caret key. Just hit shift, and that'll give you an exponent. So I hit squared, so that's a 2, arrow down, x, and then minus 3 sine x plus 1. And my second equation, I want it to equal 0, so I'm going to write y equals 0. And so that's going to be my second equation there. Now you can see that there's a lot of solutions to this equation, but what we're really looking for, again, is still to solve on a window from 0 to 2 pi. So here's one of the great things about Desmos versus a graphing calculator like the TI-84 is it's super easy to change your window. It's super easy to change step size and all that other fantastic stuff. So I'm going to go to my graph settings here in the upper right corner, and I want my x-axis to go from 0 to 2 pi. So I'm just going to go into this box right here. I'm going to delete until I have a 0. And then where it says 10, I'm going to change it to 2 pi, and I'm going to type 2 pi, and it knows exactly what I'm talking about. Now the step size typically is going to be 1, and that's fine. That's awesome. That works. But we can also put that in terms of trig values. I might say it's pi over 4, and that's going to change everything to trig values and give me a pretty good idea of where everything's at. Now, I don't really need to be all the way to negative 6 to 6, so I'm going to zoom in a little bit on that. I'm going to go like negative 2 to 2 for my y, and I think that's going to be a pretty good indication of what I'm looking for. So what I'm looking for now are just where are these two graphs going to meet. So if I go ahead and kind of hover over that point, it will find it for me. So one of my answers is going to be 0.392. And my second answer in that window appears to be right here, 2.75. All right, so what if we got a different equation? Maybe not quite so interesting, I guess, because it doesn't appear to factor or anything like that. Let's go with a little more basic one. Let's make this y equals sine of x. And for the second equation, I'm going to put 0.4. So this is the equation I'm trying to solve, and I'm going to deselect this here in just a second. But this is the equation I'm trying to solve. Sine of x equals 0.4. So in the first box, I'll type y equals sine of x. In the second box, I'll type y equals 0.4. Just like we were looking before, my window's all set, ready to go. I'm looking from 0 to 2 pi. And so I'm just going to find the points of intersection here. I've got 0.412 is one of my solutions. And I also have another solution here at 2.73. And I can try another one. Let's make this one slightly different. The cotangent of x equals 2. So now this is one we might potentially think about solving with our traditional methods, but the problem is cotangent of x, it's not that it never equals 2, it just doesn't equal 2 in the values that we're typically able to find. So your pi over 3s, your pi over 6s, your pi over 4s, any of those things. The cotangent never actually equals 2 at any of those places. but that doesn't mean it doesn't ever actually equal 2. At some point it does, but it's just not one of those nice known values that we've got. So again, like I'm going to go to y in my box 1 and go y equals, and my left side is cotangent of x. Cool. And my right side is 2, so I'm going to change that second box to 2. And now I've got to change my window because it's a little bit outside. It's hovering up here at the top. So instead of going -2 to 2 for my y-axis, I'm going to go -3 to 3. And now I should be able to see my solution. So I've got one here at 0.464, and I've got another one here at 3.605. So again, when you have these equations that don't seem like they've got a nice solution, one that's going to work out nice, the graphing calculator can help you. Desmos especially. It's going to give us some nice known values that we could potentially have. Let's try one more quick one here, and I want to show you that it actually handles the trig very well too. So let's go with this one. Oops, sorry. I'm getting all sorts of errors here. 2 sine squared of x, oops, minus sine of x minus 1 equals 0. So similar to the one we did before, but this one should actually factor. So we'll have y equals 2 sine squared, oh, why did I write an s? Sorry. 2 sine squared of x minus sine of x minus 1, and make that equal 0. You see how crazy this graph is going to start getting. I'm going to deselect this one here. But you'll see that when we get to a value that is a known value, like pi over 2, 2 pi over 3, and so on, it will actually give us those values. So when we have those equations that were factorable, we could potentially solve these with the graphing calculator as well. But we still want you to know how to do these by hand, of course, because you're not always going to have access to a graphing calculator or internet or whatever. But on a typical assessment, you would have a no calculator portion as well. But just want to show you that Desmos can handle these as well.